Hello team, today's challenge is longest domino chain, where we're given an array of domino tiles, right? The two numbers on each end of a domino tile, and we need to create the longest chain. So in this case, we have 1 and 2. The 2 matches up with the 2 on this tile, so 2 and 3, and that is our longest chain. Our longest chain, sorry. 1, 2, 2, 3, right? The 4, 5 can't go anywhere, so we don't include that. As we go down, there are longer challenges and more complicating because we're able to flip the tiles. So whereas 2, 3, it could be 2, 3, or it could be 3, 2, and we'll have to compensate with that. I'm going to admit right out front that this challenge tripped me up a little bit, right? It seems very straightforward. Feels like we should be using some recursion. I went back and reviewed my notes on Array Sum Finder from April 18th. In that case, we're going to use a lot of the same tools. And what I mean by that is recursion and backtracking. But the other parts are very different, especially because of the flipping, and especially because we don't know how long the array will end up, right? It could be all of them, or it could be, in theory, none of them, right? And we need to account for that. So trying to figure that part out is how we're going to do this. As I was going through the day, I kind of picked at it, right? Tried to figure it out. I did some research. I found a lot of examples that I really didn't like. Examples where they were putting the recursive function inside of the main function. I'm not a fan of that because it's hard to test, right? And a little bit hard to debug, but I think I found something. So that's what we're going to look at today, okay? Now, our main function is going to be our recursive function, which means that we should exit from this, right? It might become a runaway loop if we don't have a way of controlling. And our control is going to be the dominoes, right? Imagine a pile of dominoes. Everyone is taking one here and there. The dominoes are getting smaller and smaller and smaller. When you run out of dominoes, the game is over, right? It's as simple as that. So that will be our control, okay? Dominoes, I'm going to copy that because I'm going to use it in a couple places. So dominoes length equals 0, okay? If that's true, we return current. Current is a thing that we haven't actually created. That goes up here in our arguments as an empty array, right? So we have a default value of an empty array, which means the tests aren't going to be affected by that, but everything inside will be able to use that information, okay? So from here, we want to create a loop, and it feels very weird to me. This might actually be part of what tripped me up is a loop inside of a recursive function. The recursive function is the loop. So needing a loop feels very foreign to me. But in this case, we need to test each and every domino, right? And we need to build out the longest string based on those dominoes, and then test for length. So the first thing is a variable where we can check or capture the longest, right? Just like this, we're going to set that to current, which is our empty array. And then from here, we use a for loop. Could I have done this with a reduce? Absolutely. Today, I'm using a for loop just to keep it simple for my brain, okay? If you want to try it with a reduce, very much similar code, just the variables go in different places, right? So right here, I equals 0 and I is less than dominoes. Do I have it? Dominoes.length and I plus plus, okay? Now from here, we immediately want to grab that domino, okay? So domino, singular, is dominoes I, okay? And since we're grabbing that tile, well, that is reducing the number of tiles we have, right? So we should grab that. That's going to be remaining, typing it right, remaining equals, and there's a few ways to do this. One that I used forever is just to go dominoes dot slice from 0 to I, like this, with a, doing it right. There we go. And then dominoes dot slice I plus 1, okay? So it basically creates a brand new array which has everything up to but not including I and everything after I, right? Which is a pretty sound way of doing it. That's existed for many, many years and it is pretty solid, okay? Nowadays, I'm going to switch it up and use something very new, okay? Which is toSplice, okay? ToSplice takes all the same arguments as splice. The key here is that if you return .splice, it returns the deleted items. Whereas with toSplice, it returns the updated array. Okay, that's the key difference, but all the arguments are the same. So we still have our starting index, right? That's going to be I, and how many things we're changing. In this case, only one. And what are we changing it to? That would be the third argument. If we leave it off, it means that we're just deleting that, right? So we have deleted that variable or that value and returned a brand new array into remaining, okay? From here, we check, right? We check something. What do we check? Well, we want to check if current.length is equal to 0, okay? If that's true, we're going to do something. If it's not true, we're going to do something else. And I just realized I've done this before. This is an if, not a for. So that's me just randomly typing. I type for so often that muscle memory is kicking in, but this should be an if, not a for. So if current length is equal to 0, we're going to do something. Otherwise, we're going to do something else, okay? What are we going to do in here? Well, we're going to make our lives easy by destructuring first. So const A and B, that's going to be off of domino singular, because we are going to use these to test both versions. We're going to get the tile in one direction, and we're going to flip it over and get it in the other direction as well. So AB and BA, okay? That is our recursion. So right here, we grab this, paste it in. We are going to send in remaining, if I could type that word, there it is, and an array of arrays, right? It still needs to be a two-dimensional array. That's what we're expecting as current, okay? Sorry, that was weird. But right here we have A and B, okay? We're also going to test B and A, right? And the reason that I haven't captured these yet is because I don't really want to capture them. I just want to test which one is longer and then put that up in longest. In fact, I want to test these two and longest, okay? So grabbing all three of them and putting the longest one back into longest. For that, I'm going to create a helper function, okay? So up here, doing this right, getting rid of that part, we have function. I called this get longest array, okay? Just like this, we're going to toss in an array. It's actually a two-dimensional array, but we'll leave it where it is, and we return array.reduce. Normally we'd have accumulator and current in here, but we will only ever have two values. This kind of works like a sort. In fact, we could sort it and then just take the first item, right? But we can do that in one step here. So A and B, and testing A.length greater than B.length. And if that is true, then return A, otherwise return B. Hopefully that makes sense, right? We're testing the lengths of these and returning the one that is longer, okay? Getting longest array, bringing it back down, putting it in the right place, and it's going to be here, okay? So we take these three things, we bump them up, and add commas to everything, okay? Now, the return to get longest array should go into longest. So right here, we just reassign it. Brilliant. That's all we need for if the array is empty. We basically test that first tile, right? So A and B, and then we flip it over, B and A, and we say, we check which one of these is longest, and then compare that with longest itself, and whichever one of those three is longest, we put back in the longest variable. That's very wordy, but hopefully that makes sense. Down here, Now that we're past that, we have extra stuff. And what I mean by extra stuff is maybe we, if we're looking at this, maybe we've gotten these first two or even the first one, right? If we just do 1 and 2, we need to know what the last number is on this chain, right? So in this case, it's 2, which means that we should go through and only operate on things that actually have a 2. This 3 and 4 and this 4 and 0 don't make any sense, right? Because they wouldn't fit onto the chain in this position. They will later on, but not right now, right? So we go and check that tile, make sure that it actually has a 2, get it in the right position, put it on, and then we get the last number here, and we find the next tile, and we get the last number here, and we get the next tile, so on, etc. Okay. So in here, we can absolutely do that. We're going to grab a variable here. Okay. We're going to call it current end. I'm pretty sure that this could have been a const, but I'm going to leave it as a let for now because silliness. Okay. I don't have a reason for that. Let's just try it. So this can be a const. Const current end equals current at -1 dot at -1. This is saying get me the last item from the last array, right? The last of the last. That's what we're going for. So if we're back here and we have this right here, this would be the last, and this would be the last item. So the last item of the last array. Okay. With that, we can use that information as a comparison. So we have an if statement, and we check if domino.includes current end. Okay. If it does, we're going to do stuff. If it doesn't, we're just going to drop through and we're done. Okay. So at this point, we can test that. Okay. The first thing that we need to do is figure out which direction this tile is supposed to go. So again, if we're in here, we have a working tile. Let's get it in the right spot. Okay. So that's right here. We go tile, set it equal to domino.index of what? Current end, right? Just like this, make sure that it is an actual 0, right? If you leave this part off, this becomes true or false, right? The 0 and the 1, the 0 is falsy. So make it explicit, right? That's my tip here. But if that is true, it is in the right spot and we just leave it alone. Otherwise, we flip it, okay? And to flip it, I'm going to use toReversed, just like this, because that does not change domino itself. It returns something brand new, right? So if you just use reverse, you will need to create a new array first, okay? With that, we can do pretty much what we did up here. So we could grab this, copy it down, indent it in, making sure that it lines up nice, and deleting either one of these, okay? So we can just delete that because we're going to do one recursion, and then we're going to test if that is longer than longest, okay? Longer than longest. There it is. Remaining stays the same, but inside of here, we change things. So we now just have the parent array, and we expand current. And then on the end of it, we add tile. And with all of that, it should work. It absolutely doesn't. What am I missing? Taking a quick look every single time. Oh, you know what? I didn't return, did I? There it is. Longest. There it is. Okay, so at the end of the day, you do need to return whatever that longest is, right? It's still getting whatever dominoes is, but there it is, okay? So just shy of 40 lines of code, but this is my solution for today. Again, not every solution, just hopefully one good solution. I'm pretty happy with it. Let's review really fast. We passed in dominoes, and we created a completely self-contained recursive function, okay? We did that by adding some default arguments in here with the current so that the FreeCodeCamp tests don't go sideways on us, right? They don't care about that. Only us. So we made sure that we could exit, right? We absolutely need a way to force an exit. And that's what this first line does. And then from there, we do some testing, right? We test every single tile and try to build out the longest chain that we can. And if we found one, then we replace whatever longest is, right? So we're constantly doing that. Down into here, we check if we're at the start or not at the start, right? If we are at the start, then we need to test both directions of this tile, right? Both directions. If we are not at the start, then we only need to get the tile in the right spot to test the next stage. And that's how it works. That's why we don't need to test twice down in here, okay? Hopefully that all makes sense. It took me a while to get here. So if it took you a while too, congratulations, right? It's a bit of a struggle, this one. But hopefully it's all making sense. Again, if you liked it, if you hated it, what parts you liked, right? If you want to share your solution, absolutely do that. Hit me up in the comments. Otherwise, today this has been Longest Domino Chain, and I will see you tomorrow.